We are building the next generation of manufacturing floors. And the main problem we're trying to solve is, can you have a factory that doesn't need to change every time you have to change your product?
There's like this big push right now to kind of get away from bits and go towards atoms. And you're even saying like, yes, and we want to not just do it the way we've always done it.
What we need to do is rethink what manufacturing in the United States looks like today. Even in our research, we're seeing a lot of things that are possible that are magical.
We're here in Chatsworth, California at the HQ R&D facility of Machina with co-founder Ed Mehr. And how many robots are around us, roughly?
We have around 24 robots in this facility.
You knew that number really quickly. I feel like there's more.
It fills up this space pretty quickly. But yeah, no, we have 24 here, and then we have a facility twice the large size of this facility, 2 miles away.
For people who haven't watched the main episode yet and who should go do that now, can you give a quick description on what you guys are doing?
Yeah, so we are building the next generation of manufacturing floors. And the main problem we're trying to solve is, can you have a factory that doesn't need to change every time you have to change your product? Because that's a problem we have today with manufacturing floors. Every time you change your design, you change your material in a physical product, you pretty much have to build a factory around it. You need to change a lot of tooling, a lot of machinery that's specifically built for that part and that design and that material. And that makes manufacturing very inflexible. So what we're trying to do at Machina Labs is building the next generation of manufacturing floors that allows us to easily change design, easily change material without ever changing any equipment in the facility.
Awesome. A lot of people want to do stuff like that, but don't have the background that you do. Can you kind of share, I guess even before the cool previous jobs you felt, like what you were like as a kid? Were you always interested in manufacturing and robots? What led you to here?
I went to almost like a boarding style type of school. So I grew up with like the same group of kids for 30 group of kids for basically my elementary, middle school, high school. And that school had a lot of focus on shop. So very early on, we started learning welding, woodworking. So I always had a passion for building things. But toward the end of my high school, I started gravitating more toward computers because it seemed like this just, infinite world of possibilities in the computers. You could do all kinds of things, not be bounded by physical limitations. So that was very fascinating to me. So I went to school for computer engineering, and then more narrowly focused on artificial intelligence. At the time, it was statistical learning, machine learning. But when I was also in school, I left the school many times because I always was fascinated by everything that was just practical and was being done out in the industry. So I left. Once I left the school for a long-term internship at Microsoft, then I did the same thing with Google. Then I joined a startup for a while. I went to work for Sony for a little bit. So every time I had an opportunity to actually go do things, I kind of left school. So it took me a while to graduate. But eventually, kind of after school was done, I joined SpaceX as a software engineer. And that's where I was able to start thinking about how can I combine software world, which was super flexible, to the hardware world of building things. And this was still earlier days in SpaceX, so I got to exposure to a lot of different teams. I started formulating ideas around how can I kind of build a career in the intersection of both.
You've worked at like some of the coolest companies in the world in short order: Google, Microsoft, Sony, SpaceX, Relativity. What are some of the learnings that you took from each of those companies?
It's a good question. I think the most important thing, to this date is, I guess maybe like two main learnings. One is iteration is king, right? Don't let your mind be stuck in analysis paralysis. I think every successful team I worked at, either be it in Microsoft and Google or at SpaceX, was all about there's lots of unknown unknowns, iterate, build product fast, put it in the hand of your customers, in the hand of your users, get feedback. And the shorter you can make that cycle, the more likely you have a successful product. And you can do cool things that people will love and will enjoy using. So I think that was one thing. And then the other piece that I think I learned at SpaceX was, growing up, my dad, was a PhD, my mom was a teacher. So there was a lot of emphasis on becoming an expert in one thing. And then I soon realized is that to do a cool thing, you need depth maybe in one area, but you need a lot of breadth too. And I think one thing that I learned at SpaceX was go and learn the things you don't know. It's not that hard to get enough familiarity to start thinking about, at the system level, how different types of discipline can come together to do something completely new. And it took me a while to realize that's actually the source of creativity. It's the breadth that's the source of creativity. Obviously, you want to have depths in certain fields, but you need to really kind of break that kind of mental barrier that you cannot learn things outside of your expertise. Just go learn it. And it's like so easy to do now, right? With the internet, with like things like Coursera, you can learn anything. I think that was one of the most important things I probably learned at SpaceX.
Very cool. When you were doing a lot of software and manufacturing stuff at SpaceX and at Relativity, obviously there was sort of the iterate fast, question everything at its first principles and requirement level there at SpaceX. And at Relativity, it's like, let's 3D print everything. And then you sort of come here with something totally new. How did you sort of mentally channel map between the different future potentials of modern manufacturing?
I'm really big fan of working backwards from the future that is probably likely. And I think that's where fundamental thinking comes around. Like, thinking about, okay, where does manufacturing need to happen in the future? Okay, it needs to happen on Earth. It needs to also happen in this space. Then you start thinking about what is some of the biggest problems in terms of how fast can we manufacture things. Iteration cycle becomes very important. You start thinking about it. So whatever the future manufacturing system is, at volume or not, needs to have very high iteration, very fast iteration cycle. So you start putting these like really core components of, okay, what does it need to look like? Okay, in space, out of space, it needs to be fast. It needs to be able to work with material that's abundant in the universe, not just on Earth. You start putting these components together, the picture becomes a little bit more clear, but then that's a picture very far away, so you can't really directly work on it. You need to start stepping your way backwards. How can I connect today's situation into that picture? And the first step in that plan becomes your company, right? I really would love to think about it in that way, where like, yes, you think about 4 years, 40 years, 50 years out, and then kind of step your way back to what is actually today is. And really just embracing what it is today, accept it as is, and understand what is the first next step I can take to get toward that.
What are some other things outside of this specific part of manufacturing and manufacturing at large that you kind of see or think are very likely in 30, 40 years?
Yeah, so one big portion, obviously I'm a big space nerd and worked in space companies, is that manufacturing needs to happen in space. And the moment you start thinking about that, a lot of manufacturing processes we have on Earth, they just go out the window. For two reasons. One is, they're just too expensive to build this in the space. Like, it's very hard to have a 90,000 ton press in space. So it's probably not gonna be, maybe once we fully colonize it and everything is there, maybe it's a possibility, but not probably in 30, 40 years. So it needs to be something that's portable, something that's easy to ship, something that is also versatile, because we're going to be resource limited in space. So it needs to be something that can do one manufacturing operation and then switch to another very easily, and it shouldn't be process specific. So that's kind of the biggest theme for me, manufacturing space. And then when you also start thinking about manufacturing space, you start seeing, okay, what type of materials were likely going to exist in that situation. For example, for me, any carbon-based material, any composites are probably don't have a big portion of manufacturing in space, because those are hard materials to kind of come by with and make. So metals and ceramics are probably going to dominate. But most important thing, I think, is the flexibility. We need to have systems that are intelligent enough to do different types of operations just intelligently and are not single purpose, very purpose-specific kind of machinery.
I'm sure you're aware of this. Maybe you're not. Obviously, there's sort of a hype around SpaceX founders, but there's like a website that tracks this. What is it sort of like being part of that club? Like, do other sort of SpaceX founders, like, do you guys all have this secret plan? Like, all right, we built SpaceX, now we're going to go build everything else to colonize the universe. Like, what's it like sort of being a part of it?
No, I think it's kind of funny. People call it SpaceX Mafia.
Yeah.
And less so as SpaceX Mafia or Tesla Mafia, kind of Elon-led companies. I think it's less so a mafia. It's more of there's two things happen with people working those companies. One is there's a shared vision. Everybody's excited about that future. So automatically people are thinking about, what are the next steps that maybe SpaceX is not doing? right? Or Tesla is not doing. So there's no like, kind of like conspiracy sitting down together and figuring these things out. But like, I think everybody kind of thinks about it in the same way. And then because we went through a lot of, I would say, shared trauma, there's a lot of camaraderie.
Cool.
Right? I can talk with Eric and TJ, who are, like, for example, from SpaceX, worked on Falcon 9 and Merlin engine. I can call them up, ask them for help. We share resources. And it's just out of excitement and kind of alignment in the goals that we have. I think there's that. So that camaraderie out of shared trauma plus shared vision, I think, is what's making it happen.
What do you think a lot of new manufacturing kind of companies, like this new wave of manufacturing companies, kind of maybe get wrong in their approach?
But maybe we are getting things wrong in our approach, and we'll see what happens. But I think there's two common themes. One is, I think there's been two approaches to manufacturing startups. One is a lot of people are scaling what traditionally existed. And I really don't think that's the route to go. If you look back in 40s, 50s, 60s, during World War II era, we had this explosion in manufacturing capability for the purpose of the war. And a lot of people think of that as glory days, and they want to replicate that. I think there is a reason that doesn't exist. I think our workforce have moved beyond the type of jobs that kind of manufacturing was doing. There's a lot of conversations around like, well, we have shortage of labor in manufacturing because we want to replicate that same paradigm. But I think that is not probably the best way. What we need to do is rethink what manufacturing in the United States looks like today. And it's going to be a lot of automation, a lot of flexibility, a lot of robotics. So my personal opinion is a lot of folks who are thinking about it, renewing and bringing the scale to the old manufacturing technologies. Maybe in short term, there's benefits for that, but long term, I think we need just another generation of manufacturing technologies that nobody else in the world is doing, right? We're going to be pioneered the same way we were the pioneers back in 40s and 50s of setting that large scale manufacturing. I think we need to think about it the same way now, not just replicate what happened in the past.
There's like this big push right now to kind of get away from bits and go towards atoms. And you're even saying like, yes, and we want to not just do it the way we've always done it. For people that are thinking about like what they want to work on next or what they want to work on if they haven't started their career yet, what should they be focusing on? Like what's exciting to learn right now? What are the right things to think about?
I think so there's a lot of exciting stuff that's happening. Obviously there's manufacturing, robotics, which our field, I think there's a lot of room there. There's a lot of cool things happening around energy, production, like nuclear is making its way back, which I'm super excited about. I hear a lot about like new weather modification technologies, which is super cool. Obviously, space is pretty hot. Lots of companies are playing different roles in that space economy. But I think for somebody who is young, I think the most important thing is, we're just starting out, is I think now we need a new type of talent, right? That was not relevant maybe 10 years ago. And the new type of talent is the one that can be very multidisciplinary, right? Like I said, traditionally, you would go to school, you become expert in one field, and we still need those. But what we were lacking was people who could go cross disciplines.
Yeah.
And I think people who are starting to thinking about, their career, I think they should start thinking about, okay, how can I learn multiple disciplines and connect them, as opposed to become expert in one thing, become an expert aerospace engineer, expert computer engineer, expert electrical engineer. How can I combine all of them, know a little bit of all? And I think with artificial intelligence, now that is possible. Like, you can easily, as long as you know right fundamentals, maybe you go to a school for physics and learn the fundamentals, you can easily add on to that and learn different disciplines. And it's very accessible to everybody. So I think that my advice would be like, don't go deep. Maybe go deep in one area, but go also wide.
That's an awesome, unique take. You worded it very interestingly, too. I love that. What do you think some of the biggest things you've learned since founding Machina Labs has been?
I think the toughest part of starting a company in hardware space and defensive space is culture. I always as a technologist, I thought the technology was the toughest part. But now as the company's grown and we're close to 70 people and growing, I think actually the toughest part is people. How do you have a lot of mission-driven people who are excited about the mission, especially in the current society, there's a lot of like divisiveness. How can you all get excited about one mission and think of it as like, okay, that's my life purpose. I'm going to get this done. And as it's very easy to do that with a group of 10 people, 15 people. The moment you get to 70, 80 people, creating that type of alignment to get something done, it becomes much harder. Elon used to say one interesting thing. I think I heard it in one of the company all hands was like, the most important job of the leader is to think of the company and each individual as a vector. And then the job of the founder or the leader is to maximize the sum vector of all these vectors. If you want to think about it in terms of physics. And the bigger the company is, the harder it is. And I think the one that like really brings all of those vectors in the same direction is that mission drivenness and culture. So that has been an interesting kind of challenge as the company's growing.
How do you do it? Like, what are some of the things you've learned to like build that culture really well?
Yeah, so the most important thing I think is hiring. There's a saying where say A players hire A's, but B players hire C's. So it's kind of interesting. It's super important because the moment if you have like few B players, then it goes down. Like because those people hire C's and the C's hires D's and then it just goes down. So it's very important to be very selective about who you're bringing on your team. And it's tough in the early on because like people don't know your company. Like why would I, as an A player, why would I join this company? So you need to be really, I think the key to get those A players is to have a very good story and mission, but also build in a little bit in public, where people can hear about it, can criticize it, can talk about it, which is a job that you are also doing a very good job of like bringing all these companies that building these amazing things and tell their stories. But yeah, I think hiring is a big component to that. You need to have a very tough, high hiring bar to be able to do that.
This next question might sound a little weird, but I like asking founders this. Can you try to describe how you think? Like, do you have any mental models or lenses or sort of machinations of how you think your brain works that operate the way you think a lot?
My brain is a little bit chaotic.
Okay.
I think it fires like probably like I usually try to hold like 10, 20, and not intentionally, but like 10, 20 concepts in my mind at the same time. And I don't rest easy until they all kind of mesh in together well. So I hold a lot of concepts in my head, which can be like sometimes tiring and stressful. But it's always has been that way. Like, just like keep adding to my mind and I start writing. When I have a lot of concepts, start writing and say, okay, let me just put my thoughts down on a paper. And then I keep iterating on that until the full story comes in together. Initially, just a mess of things, and then they become puzzle pieces that come together. So I think that's definitely one thing that happens in my mind. And that's why I'm like, it's funny, sometimes folks in the company say it's kind of interesting to work with me because like I might send a message at 2 a.m. or 6 a.m. or 3 p.m. because that's the moment where things click.
Yeah.
But then the other piece that I would say is also learn that it's very hard to plan too far ahead.
It's very hard to do so.
Well, you could do it, but you're probably wrong.
Hard to do it well.
Hard to do it well.
Got it.
So it's also very important to not to stick to your opinions too rigidly, because I think this may be a cliche, but you need to have very strong opinions, but like change them immediately the moment you're proven it's wrong.
Love it.
Right? And because there's a lot of unknowns. So I try to kind of plan a little bit ahead, but at every step try to feel like, okay, should we change directions? Should we adjust for something? And really accept the situation as is, as opposed to try to really force it into something you want it to be. Yeah.
What's been one of the hardest technical challenges in building today's system that you have faced, and sort of how did you engineer out of it?
I think the biggest weapon you have in terms of engineering is iteration. How fast can you test something and then get a feedback and fix it? So for us we both build our software and hardware that way. So a lot of hardware choices we make early on. It's funny. A lot of people ask us, "Why do you guys use robots? Why not building a custom gantry system that can form these sheets into shape?" And the reason for it is that if I build something custom, it's going to make it very hard for me to iterate and have flexibility. With robots, I have this kinematic system that allows me to do many degrees of freedom. It has some shortcomings, but it's still a very flexible system that allows me to easily change my approach if I want to. If I would have gone to a system that was very rigid, like a gantry system, for example, it would have been very hard for me to change our approach that might not work.
Totally.
So I think, maybe I'm giving you a very general answer, but like the most number one kind of like thing that we have in mind we're building the system is like, can we change it easily? If it's not good, how fast is it to iterate and change it to something else? Basically, never let your engineering solutions become your own bottleneck.
What's some technology or research, maybe it's in or outside of manufacturing, that you're most excited to see kind of come to bear in the next 5, 10, 15 years?
Yes. So I think the biggest area that I'm excited, we are working on it too. We're actually working with some of our academic partners on this as well. What we call like robotic foundation models.
Cool.
They imagine the future of this system is that you can actually tell it to build a certain thing, and it automatically comes up with the right number of instructions and steps to build it.
It's awesome.
Think of how you can tell a ChatGPT to make you an image. What if you could tell a ChatGPT to form this part, and it would exactly come up with the right set of instructions for it, for the robots to actually do that operation accurately. So it's called robotic manufacturing foundation models. So basically applying the same architecture that you have in ChatGPT, which is transformers, but to robot actions and manufacturing operations. So that's a probably core area of R&D for us. And we're working actually with some of our university partners on that. And I'm really excited. I think there's a lot of exciting, cool things. Even in our research, we're seeing a lot of things that are possible that are magical. Like literally you tell a robot to do a certain thing and it knows how to do it. And the reason that's very exciting to me is like these type of data to train these models does not exist in the real world. So we actually have to generate that data and train the models and use them. So it's going to be like these kind of capabilities that it would have been very hard without companies like ours to develop.
What are you most looking forward to in this next stage of Machina?
We're kind of in an interesting stage. We have a pretty good product market fit. So our customers want our product. So the biggest challenge is how do we scale that? How do we go expand within the customers that we have? How to go from an engineering company to a production company, right? So it's an interesting, tough challenge, but it's pretty exciting. So that's 80% of our focus. And there's a 20% focus around what other new areas can we go to. That is also exciting. But I think, because of the maturity of the company, we're at this stage that scale is pretty important. And we're trying to see how we can scale this operation to meet the customer need.
Cool. My last question, it's also a little weird, but I think it's cool again to ask founders, what would you describe like your current life philosophy as?
When I was in that boarding school, they taught us 3 main values to live by, and I think it's still relevant to my life. Number 1 was lead with courage. And it's funny because it sounds like a cliche thing, but leading with courage means that really think about all sources of fear in your life and see if you can reconcile them. Doesn't mean you shouldn't be afraid of them, but can you reconcile them and live at peace with them, right? I think for me, a lot of times it was like fear of death, fear of like some point I'm going to die, and really getting in terms with like that's fine. But also that allows you to make decisions that maybe it's kind of funny. It almost gives you a superpower if you can reconcile your fears. I wouldn't say get rid of them, but just reconcile them, because then you suddenly can make very risky decisions. Not risky. You can make decisions that nobody else would make. That's going to change things. So that's number 1 value, I would say, like number 1 philosophy that I would love to lead my life. And I don't know if I always do it, but be able to really lead a fearless life. The second piece is, again, another cliche, but like actually, if you think about it, it's pretty impactful, is lead with love. And I think for me, love is the definition of care about other people as much as you care about yourself. And it's like as simple as that. I mean, even in this conversation, I care about you as much as I care about myself. I care about employees as much as I care about myself. I care about our customers as much as I care about myself. And surprisingly, you follow that philosophy, it has huge effect in your life. And then the last piece was like, be intelligent. And being intelligent is actually simpler than people think. It's actually easier now because we have a lot of intelligent systems that can allow us to be intelligent, like internet and artificial intelligence. But more importantly, I think just surrounding yourself with smart people makes you intelligent. So I remember one of our investors, Eric Schmidt, and I asked him what was this key to his success, and he says, I was lucky to have a lot of intelligent people around me. And I think that's just how you make yourself intelligent. So I think those are three maybe core philosophies that I think, honestly, I think if I could 100% deliver on those three values, I think I can live a very fulfilling life.
Ed, thanks for the great interview and the insights. There were some like super special and impactful ones to me in there, so thank you. And thanks for building Machina.
I appreciate it. Thank you for coming in and telling our story as well.
Dude, that was an awesome episode. Cheers. There are so many gems in that.